Hello, everyone. How are you?
Hi, sir.
Hello, how are you?
Hi, sir. How are you?
Yeah, good, good. So, everyone is fine?
Yes, sir.
Lokesh, how are you? Yesterday you were not present in the class. Any problem?
Today wasn't able to join.
Okay. Okay, so now we will start next three classes for the uh, electricity part. Okay. So here, when I saw the schedule, actually it is given first chapter as electric charge. Okay, and then directly capacitor is given. But I think when we will start the electric charge, we will finish it up to what? The complete field concept also. Right? That sequencing will be much better. Okay?
Okay, sir.
Right? Yeah, because suddenly we will just discuss about the property of charge and we'll go to the capacitor. That doesn't make any sense, isn't it? Because after that, we need to learn about the field concept, potential energy. Then only we will go for what? The capacitance part, capacitor, okay, circuit part. It will be much better, okay? So that's why we will first discuss the complete electrostatics part, all the topics of that one. Just the sequence will be a little bit different. Is that clear?
Yes, sir. Yes, sir.
Right. So let's start. If you want to see, I can show you the schedule and the chapter name also, but I think you also will have those schedule with you, isn't it?
No, sir.
Hmm? Not there. Okay, don't worry. I will just show it to you. Right. The first unit we have is the electric charge, field, and the Gauss law. Okay. See that? I will just share the screen. Okay, and then we will continue. Have you solved the questions on the vector?
Still solving, sir.
Right, right. Complete it. Okay, na? Complete it. There are around 40-50 questions are there. First complete those one. Then some additional assignment I will give you on the vectors. Okay. Although it is not directly many questions are there, but vector is a very important topic to understand the further chapters like kinematics. If we want to understand, then we will definitely need the concept of vector further. Okay. See, my screen is visible. Check it.
Yes, sir. Yes, sir.
Yeah, see, the first part what we have is the electric charge, field, and the Gauss law. Okay, so electric charge, Coulomb's law, which will give us the force and conservation of electric charge and the process of charging. Electric field concept, electric field due to the distribution of charge, like what will be due to the line charge, ring charge. Okay, and then we will learn how to calculate the electric flux integration method as well as the Gauss law method. Okay. Once we learn about the charges field, then we will go for what? We'll go for the electric potential part. Okay, right? Check it. And then capacitor. So capacitor will become simple if we understand these topic first. Means electric charge force concept and electric potential concept. Once we have learned, then the capacitance concept will become easier for us. Okay. Then we'll go for the current electricity part, magnetism, and EMI AC. Okay, so these are the topic list we have. Okay,
It's only till
so
AC.
yeah,
No, like magnetism, what do we have? Like earth magnetism, what do we have?
No, Earth magnetism is not given.
Okay.
Check it.
No, I'm asking if there is earth
Magnetic field.
magnetism. Only amperes
No,
law,
as
like
per
that.
the magnetic field, it's only the current carrying wire magnetic field is given. Okay.
Oh,
As per
okay.
the
So no
guideline, don't
magnets induced current.
no, no, induced current will come in EMI, na?
Okay. Okay. Yes, sir. Yes, sir.
Magnetic flux, then electromagnetic induction,
Then
motional
AC. Okay.
EMF, right? Then alternating current circuit we have.
Okay, sir.
Okay, so these are just the guideline. I got it from this source. But if any extra content will be required, that will definitely we will discuss. Okay, but let's start with the electric charge and field. It will take some time to reach there, isn't it? So let's start with the electric charge, right? Tell me, everyone, ready?
Yes, sir.
Yes, sir.
Okay, just give me a moment. I will. Right, just and after every class, now I will share with you the notes also. Okay, so that you can go through those what we have discussed in the class. Okay.
Okay.
Actually, this is what I have just discussed with one of the student. Right? All these things we have to discuss it for you also, but it will take some time, isn't it? We are just going to. Oh, I did not. Right. Chaliye, what can be done? Actually, I had to share this notes with the student and I forgot. Okay, chaliye, let's continue now. Okay, chaliye. Electrostatic part, na, it's a very interesting, very interesting one. Let's see why. Let's start with the electrostatics. Okay, so in electromagnetism we have, now here you will be seeing directly, we are going to the physics part. Okay, like in mechanics part, what happens to build up about the actual mechanics, we need to learn about the vector concept. So that's where we have started the first part. Okay, now we are going to start directly with the electrostatics part now. Okay, my screen is visible now.
Yes, sir.
Yes, sir.
Right. So in electrostatics, what we discussed in electrostatic, we discussed about the charges which is in what static condition. Okay. In electrostatic, what we discuss? We discuss charges which are at rest, which are
So,
at.
sir, in mechanics, we don't discuss fluid mechanics. Fluid
No, I
mechanics.
don't think fluid is there. I just need to check it.
Why
The
it is not there, sir?
There are limited part of the this AP exam doesn't have the
Okay.
complete physics part, na?
Yes, sir.
Right?
Yes, sir.
When you are writing about this one, so limited part. Okay. Once you write this one and you want to learn physics, don't worry. You connect with me. I will teach you all the 30 chapters of the physics. Okay.
Of course, sir. Of course.
Right. So for me, teaching, there is no problem. You can discuss anything from chapter number 1 to chapter number 30. There are around 30 chapters in physics, right?
Yes,
So
sir.
for exam relevance, these 7 and 8 chapters, that is only important, isn't it? And
Yes, sir.
different course has different requirement also, no? So that may be the reason. Okay, so charges which are at rest, or sometime if the charge is moving, na, so then it must be moving with very slow velocity. Okay, or moving with very less velocity. Okay, that's why it is called as what? Electrostatics. When the charge starts moving, when the motion of charge take place, that thing we discuss in what? Electrodynamics, which is also the chapter name is the current electricity. Okay, the motion of charge is called the flow of current. Okay, so now when we discuss about the charges, what are the type of charges we have? Tell me, what are the type of charges we have?
Positive, negative, and neutral.
Yes, there are simply two type of charges are there: positive charge and negative charge body. Right, there are two type of charge bodies there. One is the positive charge body, other one is the negative charge body. So tell me, what does it mean by positive charge body
A
and
body
negative
having
charge body?
number of electrons,
A body having,
less number of electrons in its neutral condition.
yes. So how can we create? Yeah, that's correct. It has less number of electrons compared to the proton. And negative charge means what? More electron compared to what? The proton, excess electron. So please tell me, how can we create a charge body? If I want to create a negative charge body, what I should do it?
Give it electrons.
Yes. If you want to create a negative charge body, how we can do it? Give some extra electron, isn't it? Give some extra electron to it. So now tell me, how can we create the positive charge body?
Taking out some
Taking,
taking out some electron.
yes, taking, or you can say that removing some electron from the body. Is that clear? Removing electrons from the body. So now tell me, why not removing the proton? Why not giving the proton? I want to create a
Because
positive. Yeah, please tell me.
it has a higher mass compared to an electron, so it will be less.
Is the mass is responsible for not movement of proton or something else?
Protons are present at the center, whereas electrons are present in the
Yes,
orbits.
that is the correct answer. Because see, electrons are doing the orbital motion. It is in the orbit, right? So removal of electron from an atom is very easy compared to what the removal of proton, right? Why? Because proton reside inside the nucleus, isn't it? So,
Yes.
if I just ask you to do a comparison, what is the energy needed to remove an electron from the hydrogen atom? Is it 13.6 electron volt? Just
Yes.
a rough idea, tell me. 13.6 electron volt. That is the minimum amount of energy you need if you want to remove an electron from hydrogen atom, right? And if I ask you, how much is the energy required to remove a proton from hydrogen atom? Any guess? Any rough idea?
Not so. But more
Mhm.
than more than 30.
More than that. How much? How much more than that? Two times? 10 times?
Maybe more
100
than that.
times?
Don't.
What is that written? Mega electron volt. something like that, 10 to the power 6. Actual value it is around 6-7 mega electron volt. You see that 10 to the power 6 time more energy is required. Understood? That's why if you want to create a positive charge body, it's better to remove the electron from the body rather than giving the proton to the body. Is that clear? That is the
Yes,
reason.
sir.
Okay. So that's why. Is that clear? So now there are two type of charges, which is the positive charge and the negative charge body we have. Now there are some properties of the charge. What are the properties of charge? Tell me. First and important property of the charge is what? Charge is quantized. Understood? What is the charge is? Quantized meaning? Meaning is what? Can we only give charge in the integral multiple of charge of electron? Isn't it? Either I
Yes,
can
sir.
give 1 electron to the body or 2 electron or 20 electron. Can we give 19.5 electron to a body?
No, sir.
No, and we cannot remove the 13.6 electron from a body, right? If I am giving electron to the body or removing the electron from the body, it should be always in the integral multiple of what? Integral multiple of the charge of electron. That is the meaning of charge is quantized. So if you want to, can you write it a mathematical way that charge on a body is always going to be plus minus any.
Yes, sir.
Tell me, charge on a body, can we write it? It is going to be plus minus any, where n is always going to be an integer and e is what? E is the charge of electron.
Charge
What
of
is the charge of
1.6 into
how
10
much is
power
the
minus
charge of?
19.
Yes, charge of electron is minus 1.6 into 10 to the power minus 19 coulomb, right? Coulomb is the SI unit of the electronic charge. Okay. And proton charge, what will be the charge of proton? Proton
Plus
charge is just
1.6.
going to be plus 1.6 into 10 to the power minus 19 coulomb. Is that clear? Sometime mass will be also required. Just let's write it. What is the mass of electron and mass of proton?
Mass of electron 9.1 into 10 power minus 31 kilogram per gram.
9.1 into 10 to the power minus 31 kg. And mass of proton is
1.66.
1.67 into 10 to the power minus 27,
27.
28, just 27 kg.
27.
And this is also what? Same as the mass of
Neutron.
neutron also, isn't it? Mass of proton and neutron are almost equal. And mass of electron is very small compared to what? The mass of proton. Okay. So there is a relation between that also. Can we say mass of electron is actually 1 by 1840 times of the mass of proton,
Yes, sir.
right? So that's why electron is very light compared to what? The proton and the neutron. Is that clear? The first important thing we have learned is that what? Is that charge is quantized. Okay? So any object is going to have the charge. It will be always the integral multiple of what? The charge of an electron. Clear? If it is given some charge, the body will get negatively charged, or we will say it's a negative charge body. If some electron has been removed from the body, it will get positively charged, right? Now, the second property what we have, tell me, charge is what kind of quantity? It is a scalar or vector?
Uh,
Yeah, charge is a scalar quantity. That means if I want to find out what is the total charge, can I write it? Total charge is going to be just the algebraic sum of the individual charges, isn't it?
yes.
Algebraic sum of the individual charges. Like something here, if I say in this container there are some charges 3 coulomb, there is another charge particle of minus 2 coulomb, there is one more charge particle of plus 8 coulomb. So what is going to be the total charge here? Can we say the total charge is going to be
9
plus
coulomb.
3 coulomb plus 8 coulomb, and the other charge is
Minus
what? Minus 2 coulomb. 11 plus 2. So that means the total charge here is going to be what? Plus 9 coulomb. So charge is a what? A scalar quantity. That means to add the charges, total charge on the body, we don't need the vector algebra or anything. We can just add the charges just like how do we add it in the algebra. Is that clear?
Yes, sir.
Oh, the second thing about the charge is what? It is a scalar quantity. Next point about the charge, tell me. Charge is what? It is a frame dependent quantity also. Charge is what? Frame independent quantity. What does it mean by frame independent quantity?
It depends from one factor. It's like same from a moving body and same from state. It varies.
Yes. But frame independent quantity means what? It does not changes its value with the observer change. Isn't clear? Frame means what? An observer, isn't it? See, displacement, velocity, acceleration, all these things are dependent on the frame, right?
Yes,
But
sir.
charge is what? It's a frame independent quantity. That means charge of an object does not changes with change in observer. Clear? Next point. Charge is independent of the mass also, you can say that, okay? A body charge does not depend on its mass. Clear? That is another point you can write it. Charge is what? Is independent of the mass. Clear? Charge is what? It is independent of the mass as well. Now the next point. Now tell me. Now, two type of charges are there, positive and negative charges. So whenever these charges will be brought close to each other, in front of each other, what will happen? Are they going to apply the force on each other? Isn't it? So actually we have the two type of forces acting, isn't it? What are the two type of forces acting? Please tell me.
Repulsive force and attractive force.
Yeah. Here I am going to keep a positive and negative charge, okay, in front of each other. What they will do is the
Attract
positive
each other.
charge will be attracted towards negative and negative charge will be attracted towards the positive, okay?
Yes, sir.
And one more thing about this one, tell me, is the electrostatic force or electric force between the two charged particle, can we say that it is always along the line joining the two charged particle?
Yes, sir.
Please tell me. So force between the two charged particle can be what? Attractive. Here we have taken two opposite charges. Two opposite charges. So that's why what they are doing, they are applying attractive force on each other. And if we take the similar charges, maybe both positive, right? Or maybe both negative. Then what will happen in these two situations? In these two
Repulsive.
situations, they will be what? Repelling each other,
Yeah.
right now. So here what will happen? They will be what? Repelling each other with equal force. So this force will be called as what? The repulsive force. Is that clear? Please tell me. So there are
Yes.
two type of forces we have, attractive as well as the repulsive. But one thing for the electrostatic force we are sure about, that electrostatic force is always going to act along the line joining the two charged particle. Okay, so it is always going to be along the line joining the two charged particle. Is that clear? Now let's take an example. Tell me, In this example given, we want to create a charged body of 1 coulomb charge. Okay, understood? If charge on a body, charge on a body or a particle is 1 coulomb plus 1 coulomb, then can you tell me how many electrons is removed? Na? Please tell me. I have created a positive charge body. So it means I must have removed some electron. Na? Then how many electrons has been removed? Please tell me. If a charge on the body is equal to plus 1 coulomb, then can you tell me how many electrons has been removed from the body?
1 by 1.6 into 10 power.
Yes. Simple. What we should use it here? Should we use it Q equal to NE? Isn't it? We want to
Yes, sir.
create what? We want to create 1 coulomb charge. So how many electron I need to remove? Some n number of electron we need to remove. So charge of one removed electron is going to be 1.6 into 10 to the power minus 19. The number of electron removed, what we are getting? 1 by 1.6 into 10 to the power minus 19. These many electron we should remove it. Is that clear? That is an integer. Don't worry about that one, okay? Because numerator
Sir,
there
ये
is a
integer
factor
है.
of
1 by
10 to the
1.6
power
into
9.
10.
Yes,
16 into 10 to the power of
check it
20.
now.
Okay, okay, okay.
Is it
1 by
integer or
16.
not?
Yeah, yeah, yeah.
It's a 10 to the power 19 by 1.6, na? Right? Or you can write it 100 by 1.6 into 10 to the power 17. That makes it integer only, na? 100 by 1.6.
Yeah, it's 625 into 10 to the power of 16 or 15.
Yeah. So that's why it makes it integer. That's why this question is generally given, because we think that, okay, sir, how this can be an integer. Understood? Okay,
That's it.
right. Now, the next thing we are going to discuss is going to be, now we have seen that there are what type of forces? Two type of forces, right? Electrostatic force can be of what? Two type of. What are those two type of? It will be attractive as well as repulsive. Now the question arises that how much is the electrostatic force? And that is going to give us a lot of question. Is that clear? So now we are going to start with the topic which is going to give us a lot of questions for our practice. Okay, and for exam point of view also. Can you tell me what is the law we got it for the force between the two charged particle?
Coulomb's law.
Tell me. It is called Coulomb's
Coulomb's
law
law.
of electrostatics. Okay, Coulomb's law of what? Electrostatics. So what it says that if we keep the two charged particle, let's say this is the Q1 charged particle, this is the another Q2 charged particle, and they have been kept some r distance from each other. And keep in mind the surrounding medium in which these charged particle is kept, that is vacuum. Okay, the medium in which these two charged particles are kept is what? Vacuum. Okay, so what will happen? Force between these two charged particles will be proportional to what? It will be proportional to their product of the charges. Okay, right? And it is going to be inversely proportional to what? The distance square. So if we combine them, what we are going to get it? We are going to get a constant K Q1 Q2 by R square. And keep in mind here, I have only written the magnitude. Here I am just writing the magnitude of electrostatic force. So magnitude cannot be negative, isn't it? So if I want to calculate the direction, how do we calculate the direction? So direction we will always calculate using what? using this method that this force must be what? Along the line joining them. So if it is both charges given similar nature, we will apply them as the repulsive force. And if they are of opposite nature, then we will apply them what? In the attractive direction. Is that clear? Now, what is this K called as? Can you tell me?
Coulomb's
This
constant.
K is called as the Coulomb's constant. And what is the value of K? Also, tell me one thing here. Is the Coulomb's constant, this K, it's a universal constant or is it the medium dependent constant?
Medium dependent constant.
Please tell me, every one of you. Please interact, all of you, okay? If you know the
Medium
answer,
dependent.
very good. If you don't know the answer, it may incorrect. But when you then you will learn it, isn't it? And that's what the class is for, na? So that you will learn and do better, isn't it?
It's medium dependent, sir.
Yes, it is a medium dependent constant, okay? So that's why its value will keep on changing if we change the medium. That's why I have taken in the first example or in the first basic part, we have taken the vacuum. Vacuum is also called as what? Air. It is also called as what? The free space. Okay. So this is the Coulomb's constant, and Coulomb's constant is not an universal constant. As the medium changes, the value of Coulomb's constant will keep on changing. Okay. So what is the value of this Coulomb's constant? 9
into 10 power.
into 10 to the power 9 Newton meter square by Coulomb square. Is that clear?
Yes, sir.
Now, this Coulomb's constant, sometime you will find out written like this: 1 by 4 pi epsilon naught.
Epsilon naught.
That Coulomb's constant, sometime you will find out written like K equal to 1 by 4 pi epsilon naught. So the K value is 9 into 10 to the power 9 Newton meter per Coulomb square. So the value of epsilon naught, we can calculate it now. 4 pi and everything is constant. So the value of epsilon naught become 8.85 into 10 to the power minus 12. And its unit will become what? Coulomb square by Newton meter square.
Newton meter.
So that means this Coulomb's law of electrostatic, what will be like this? The magnitude of force is going to be 1 by 4 pi epsilon naught Q1 Q2 by R square.
Yes, sir.
So what is this epsilon naught called as? So epsilon naught is called as,
Permittivity
can you
of
tell me the name of epsilon naught? This is called
permittivity of free
permittivity
space
of
or
free, right. So if I'm writing naught, that means we are representing the vacuum as the medium, or we are taking free space as our medium, okay? So this represents what? Permittivity. What does it mean by permittivity? How much a medium can get polarized. Like whenever charged particle is there, isn't it the particle in the surrounding also will get charged? Please tell me, does it happen or not? If I keep a charged particle at a point, isn't it it's going to create some more charged particle in its surrounding?
Yes, sir.
yes, sir.
So this permittivity tells us about exactly same thing, that how much it is permitting, and how much it is allowing the medium to get charged. Is that clear?
Yes, sir.
Yes, sir.
Is that clear? So that is called the permittivity of the free space. The Coulomb's law of electrostatic. Now it gives us what? The force between two charged particle. But one thing we have to make sure, these two remains the particle. These two remains what? The particle. These two should remain the point charge. Means you cannot apply directly between a ring and a rod. You cannot apply the Coulomb's law between what? A ring and the rod. For that, what we have to do? We have to learn about the concept of electric field. So that is the next topic we have. But before that, let's focus more on the electrostatic part. First, we understand about the point charges. So can we say that only for what kind of charges we are going to write this equation? Only for the point charges, or you can say that only for the charge particles we are going to apply this equation. Is that clear?
Yes, sir.
So now we know the force between the two charge particle. Okay. So now let's do some example now. Okay. Now we are going to discuss some of the example on the Coulomb's law of electrostatics. Okay. Let's take our first example. Acha, before doing the example, there is a term called principle of superposition. Even though if I don't tell you the principle of superposition, you will be able to solve the question. So can I just take a question, solve it for you, and then I will tell you you have already used the principle of superposition? Please tell me.
Yes, sir.
See, in the question, what is given to us? An equilateral triangle is given to us. Okay, an equilateral triangle is given. Side of equilateral triangle is A. And at the three corner of equilateral triangle, 3 point charges are kept. Okay, 3 point charges are kept. Now they are asking the question, find the net force on one of the charge particle. Do you understand the question? Find the net force on one of the charge particle, net electrostatic force on one of the charge particle. Understand my question? What did they ask? Find net electrostatic force on one of the charge particle. So which charge particle you want to find out? Tell me. You can take anyone, same answer will come, isn't it? So which corner charge particle you want to consider? Let me write it A, B,
B B
and C.
B
B corner. Okay. So tell me, B corner, how many particles are going to apply the force on the B corner?
2
Two particles.
Two particles, isn't it? A will apply force on B and C will apply
C
force
will
on B.
apply.
So now let's write it, how much it is going to be. So I'm just going to put it here and show it to you. Tell me, how the C will apply force on B? Is that going to be force on B due to C? You know this
Yes,
kind of
sir.
symbol we use it. Okay, na? FBC. That means force on B due to C.
Due to C.
Understand the meaning of, if you see somewhere written like this kind of expression in the question, what is FBC? That means force applied on B due to C. And is it going to be repulsive in nature? Please tell me.
Yes, sir.
So
Same
C will
charges.
be repelling, same type of charging. No? So C will be repelling the B towards left. Now tell me, what is going to be the other force? Who will apply the other force?
A.
A.
A. Can I apply it in this direction? Along the line joining A and B? Can I
Yes,
call
sir.
this is the force on B due to A?
Yes, sir.
And
Yes, sir.
what is the value of this force? Is this force is equal to K, and the arrangement is given in the vacuum. Okay, na? It is given in the problem that the charge particle are kept in the vacuum or in the free space. So tell me, what is going to be FBA? Is it going to be K Q1 Q2 by A square?
Yes, sir.
Force on B due to C, what is that going to be?
Same.
Force on B, same going to be?
Yes, sir.
So K Q1 Q2 by A square. Now tell me, what is the net force then?
It will be resultant of the both.
Resultant. How do we calculate the resultant of two vector? Force is a vector quantity. Just yesterday we discussed.
Yes, sir. Angle between
Right.
them
So
is
that's
60
what.
degrees. So we can
Yes. Is this
calculate.
angle is 60 degree equilateral triangle?
Yes.
So that means if the angle between these two vector becomes 60 degree.
60 degrees. Yes, sir.
So what is going to be force? Is the net force is going to be K
FBC
Q
square plus
Q by A squared, right? F1 A square. Next what?
plus
Q
FT
square
square plus
plus
2
2
F1 cos 60.
F1 F2
Cos
and
60.
cos
60.
60, isn't it? Right? Now let's
Yes.
simplify it. Cos 60 is how much? 1 by 2, isn't it?
1 by
Cos
2.
60 is what? 1 by 2.
1 by 2.
Can I cancel out this 2 and 1 by 2?
Yes, sir.
So is that coming root
KQ square by A square.
3 times of
Root 3.
KQQ? So KQ square by A square.
Root
That is the net force
yes, sir.
acting on the any corner charge particle. Same will come now in the question. Understood? It's the same thing written. This is the same.
Yes,
This is
sir.
the same. This is also become same, right? So can I write it? Root
Yes.
3 times of k q square a square common 1 plus 1 plus 1. So root 3 times of kq square by a square. So that is the net force acting on the charged particle. Is that clear?
Yes, sir.
You know, you have already used the principle of superposition, right? So if you want to know the name of the topic, so actually the topic which we have used it here is called principle of superposition. Okay, what is that principle called as? Principle of superposition. So principle is what it says, like if an arrangement is given to us, let's say this is the charge particle 1, right? There is another charge particle 2. Here Q1 is there, here Q2 is there, here Q3 is there. There will be another charge particle, 3 charge particles there. So can I say this charge particle 1, any charge particle you want, is this charge particle 1 is going to find the force due to all the different charge particle?
Yes, sir.
Matlab, it will be experiencing one force on 1 due to 2, make it negative, both positive. That is going to be force on 1 due to 4. This charge particle, let's say it is negative, the force on 1 due to 5, isn't it? So if I want net force acting on charge particle 1, what should I do it? So this charge particle is experiencing many forces, na? Forces due to many other charge particle. So should I do one thing? I should find out force on 1 due to 2 plus force on 1 due to 3 plus force on 1 due to 4 plus, like that. But you see that, did I just add the forces? Did I just add their magnitude? Or did I write something, this arrow kind of
Vector.
thing?
Vector.
What is that thing represents?
Vector. Vector.
Yes. That means the net force on 1, if I want to calculate it, then I have to calculate the force acting on the
By
particle
vector
1
addition.
due to all other charges present there. And then we should add them what? Vectorially.
Vector
Actually,
addition.
that is what we have done it in this question, isn't it?
Yes, sir.
So we first found out what is the force acting on the B particle due to A, due to C. Let's say some more charges are there. So due to those charges, we will calculate it. And after that, what we will do? We will add them vectorially. Is that clear?
Vector. Yes, sir.
So can we discuss another example if you understand this one?
Yes, sir.
Right. Let's discuss this example. In this example, I am giving you a right angle triangle, okay? Right angle isosceles triangle I am giving. So that this side is A, this side is A. Here charge is 2q kept. Here charge is plus q. Here it is plus 2q. And here it is minus 2q. So let's take it minus 3q. Now find the force acting on this corner particle. Okay, understand the question? Find net force on particle A. So what you will do it the first thing, please tell me. How are you going to start?
So first we draw from like which sides the force is acting and take the result.
Yes, first we will find out what forces are acting on the A particle, isn't it? It will be experiencing two forces actually, isn't it? One due to plus Q, other one due to minus 3Q. Then we will draw these forces, we will see their direction, and then we will add them as a vector. Is that clear?
Yes, sir.
So please tell me, are you getting this one or not? Please tell.
Understanding, sir.
Okay, so please try it once just for a minute. Then we'll discuss this one, and after that, we'll go to the next example. All of you, please tell me, is it okay if we discuss in this way, right?
Yes, sir.
I hope you are getting the questions, concept. After that, we are discussing the examples also because anyway, you have a first part of your paper is a MCQ type, isn't it? So you need lot of practice of the question also, all different type of questions, isn't it? Please tell. Right? So tell me, what is going to be the answer here? So on the A, can I say plus Q, how it will apply the force? Plus Q. What
First
kind
you
of
will
force?
apply downwards, sir.
Downward? Why repulsive, na?
Repulsive force.
Yes. Okay. Let's call it B. Let's call it C. Can I call it this is the force on A due to B? Next, tell me, what kind of force C is applying?
Towards itself.
Repulsive or attractive?
Attractive.
Yes. It will be trying to attract towards itself the force on A due to C, isn't it? Now tell me what are the values? Force on A due to B. Is it K, Q, 2Q by A square, right? And
Yes, sir.
force on A due to C, is that equal to K, 2Q, 3Q by A square? And how these two forces are acting? Tell me everyone, Vacho. Are they perpendicular to each other?
Yes, sir.
Yes, sir. 90 degrees.
Isn't it? Now we know the both the vector magnitude, and we also know that how these two vectors are acting with each other means what is their angle between them. So can I get the net force now?
90. Yes, sir.
So how much it will come? It will come 2k q square by a square, and that is 6k
6
q
kg.
square by a square.
Right.
So net force is going to be under root of
4 KQ.
2kq square by a square whole square plus
Plus 0.
2 into this into cos 90. That's why I did not write, because the moment I will write cos 90, it makes it 0, isn't it?
0.
So why should we write it this much term so unnecessarily, isn't it? Now just simplify it. Is it coming 4 and 6 square, 36? Is it coming under root of 40
Under root 40x.
a q square by a square?
Yes.
So actually that is done. 40 you can also further simplify it as per the
Root 10.
given option to you, isn't it?
Yes, sir.
Please tell, do you understand? 2
Yes,
root
sir.
10 you can keep it, okay? Now let's make it a little bit different here now in this question. I think we are discussing the third example on this one, right? 1, 2.
Yes, sir.
In this question, what is given? A square corner is given, okay? And
Sir,
on the
you said
corner of the square,
in
4
superposition we
charges are
add
kept.
all the forces like F1 2 plus F1 3 plus F1
Yes,
4.
yes. Yeah.
But here we are taking F net Y like square root.
So we are adding only, na?
Where we are adding, sir, we are taking square root, then we
No,
are
no.
adding.
After.
We have to do like FAB plus
Mhm.
FAC, no?
Yes, so how do we add the two vectors? This is the
Okay. A
FAC
bar
vector
plus B bar is equals to okay. Yeah.
and this is the FAB vector. Now I want to add these two vectors, isn't it? So if two
Yeah.
vectors are we are adding, so isn't it we are going
Yeah.
to get the resultant like this?
If
This is
suppose
going to be my resultant.
suppo
So either I. Mhm.
suppose both are I caps, let's say both are I cap, then we can add directly I cap, no? Instead of taking resultant.
Yes, very good. That's
But
it.
here it's not like
Yes,
that.
if
One is I cap, one is J
yeah,
cap, like that.
yes. That's why we have to take help of what? This under
Resultant.
root of f1
Okay.
square plus f2 square plus 2 f1 f2 cos theta,
Understood, sir.
right? If
Understood.
two forces are in the same direction, we can directly add it. If they
Yes,
are in
sir.
the opposite direction, we can just subtract them. If they are at any other angle, right? Then we should take help of f1 square plus f2 square plus 2 f1 f2 cos theta,
Yes, sir.
right?
Yes, sir.
Now, in the question, what is given? Just a moment. In this question, what is given? These two corner charges are positive and the other two corner charges are negative. Understand? Two opposite corners are having plus q charge and two other opposite corners are having 2 minus q charge. Okay. Let's call these corners here as A, B, C, and D. I want to find out net force on the C corner charge. Understood? I want to find the net force on the C corner charge. How do we find out? So will you think about this question? If I give you some hint about,
Yes, sir. We'll think.
right? C.
Sir,
Tell
f of
me
root 2
if
minus 1 by 2, sir.
f of
KK square by A square into root 2 minus 1 by 2.
root 2 minus 1 by 2. Yeah, I think like that will come. Let's see. Can I say this is FCB attractive?
Yes, sir.
This is FCD attractive.
Yes, sir.
Is that going to be
Yes, sir.
FCA repulsive. Now you have to find the resultant of these three. Please tell me, can it be done?
Yes, sir.
Values are known. This value is K Q by A square. Yeah, please tell me. Any confusion?
No,
Please tell me.
no,
Any
sir.
confusion in this one?
No, sir.
Right. FCD is going to be how much? KQ square by A square. And what is this going to be? KQ square by root 2A
Root
square,
2 by
isn't it?
8
It's a
whole.
diagonal,
Yes, sir.
right? Now you have to add these three vectors. So just take this question, add it so that it will help you in addition of this question also, and at the same time it will help you to understand about the vector thing also. Okay, this vector, and this vector, right? All three vector magnitude given, angle given. Please try to find out that one.
So
Okay,
should we take components
you
of
have to,
FCD and FCB along AC, sir?
yeah, we can take it. Okay, but
Yes, sir.
here, if you take it, it will become correct. But it is always better to take the component along the I cap J cap. Here too it is okay. Here if you take the component along this or other direction also same answer you are going to get it. But
Yes, sir.
whenever we take the component, we make one thing sure that the two axes about which I am going to, or two axes along which I am going to take the component, those two must be perpendicular to each other, isn't it?
Yes, sir.
So here, are we sure about, are we sure that this axis and this axis are exactly perpendicular to each other? Please tell me. These two lines are the side of a square, na? So that must be perpendicular
Perpendicular.
to each other, okay? So you can take it the component method, or you can directly find the resultant by finding the resultant of these two first and adding that resultant with the third vector. So that I will keep it for you to do it, okay? So next we have to discuss about few more question on the electrostatic Coulomb's law, where we will find out where should we keep a charged particle so that net force is zero. Okay,
Null point.
equilibrium of charged particle, that we will discuss, and then we will go for the dielectric constant, relative permittivity. Okay, so these things we will continue in the next class. Okay, so I hope everyone understood what we discussed today.
Yes, sir.
Yes, sir.
Please tell me.
Yes, sir.
Yes, sir.
Right, so please, I have a sincere request that please join on time the class and be sincere in everyday class. Okay, because if you are going to uh, join everyday class, you will definitely learn something in each class, and then it will help you in when you are going to practice the questions. Okay, right, all of you, please take care, and let's meet it tomorrow. Okay, any day, maybe Saturday or maybe any day. If I will be late, I will be definitely inform you earlier. Okay, but my habit is what, should not be late. Okay, na,
Okay.
right? And whatever questions I will keep on sending in the group, please do those questions. Okay,
Okay, sir.
Okay, sir.
right, Vacho. Take care and good night. Let's meet it tomorrow.
Good night, sir.
Good night, sir. Tata.
Good night. Take care. Sandeep. Okay.